Yes students, welcome to our video lecture. In today's lecture, we are going to study a new formula of limit and focus on sums of this formula only. Limit x tends to a, x raised to n minus a raised to n upon x minus a is equal n into a raised to n minus 1. Students, this is the formula which we have to accept without proof. Try to understand that the power of x and a are same as n, and denominator will have only, students, x minus a. So this particular formula we are going to apply in today's sums. This particular formula, students, we are going to apply in today's sums. So all of you please concentrate. I am starting with MCQ 10. Now all of you please pay attention. Now we are going to finish off one section. So I am doing questions 10, 11 and 12 of section A. What is the value of limit x tends to 3, x raised to 4 minus 81 upon x minus 3. I am writing the 11th sum also. Limit x tends to minus 1. It is x raised to 5 plus 1 upon x plus 1. Okay. And then students, I am writing MCQ 12. Y is equal to 10 minus 3x. As x tends to minus 3, then students, we have to check y tends to what? Okay, now all of you please concentrate while we go for application of this formula. The main part of the sum is this: x raised to n minus a raised to n, and there must be a negative sign between x and a in the numerator as well as denominator. Students, observe this. There must be a negative sign between x and a in the numerator as well as, students, denominator. Here, power of x is 4. So this term must be modified as x minus a, means x raised to n minus a raised to n. All of you know 81 is written as 3 to the power 4. So this changes to limit x tends to 3, x raised to 4 minus 3 raised to 4 upon x minus 3. Now compare with this formula, x raised to n minus a raised to n upon x minus a. The answer is n a raised to n minus 1. Our n is 4, a is 3 raised to n minus 1, sorry. So n minus 1 will be 4 minus 1. So 3. So this will be 4 into 3 cube. So 4 into 27. So this answer, students, is 108. And according to the option, students, the answer is option D. So the correct answer is option D. Now we do sum number 11. Focus, students. I told you there must be a negative sign between x raised to n and a raised to n. But here it is a positive sign. Now all of you know minus 1 raised to 5 will be minus 1. Minus 1 raised to odd power will be minus 1. So now this is simple mathematics, but very important mathematics. Limit x tends to -1, x raised to 5 minus -1 raised to 5 upon x minus -1. Now check this transformation from this given. -1 raised to 5, students, is -1, and outside I have written a negative sign. So this whole term will simplify to +1. Same way here also I have written minus of -1. If I open up the bracket, minus into minus becomes plus. So for the application of formula, we should have a negative sign between x raised to n and a raised to n, and a negative sign, students, between x and a. Now, as per the formula, the answer is n. A is -1 raised to n minus 1. So the answer is 5 into -1 raised to 4. -1 raised to 4 is +1 into 5 is 5. So the answer is option. According to the option, the correct answer is B. Now this is very simple. As x tends to -3, we have to find what is the value of y. So simply take x as -3. -3 into -3 is +9. So the answer is 19. So the correct option is, students, option C. So now, students, we are finalizing. Now, students, we are finalizing one section. Now we have completed section A. So now, students, we go for section B. It is VSQ, very short questions. Now, students, we go for, you can say, section B. And let us complete the section B also, students. So, all of you please concentrate here. Today's formula is one of the most interesting and you can say a phenomenal formula for the application of limit. This is the most interesting one, students. Now, I think we have done only up to sum number 7. So from A to sum number 14, students, we are going to complete section B. So please all of you pay attention and try to understand the logic which I am explaining. So students, 3 sums we will do. Section B, we start with the 8th sum. Find the value of limit x tends to 5. Limit x tends to 5. It is 3x plus 5. Okay, this is very simple. Then let us do the 9th question. Find the value of limit x tends to -3. It is cube root of 2 minus twice x. Okay. Then, students, I am writing sum number 10. Limit x tends to 0. 3x square minus 4x plus 10 divided by 2x plus 5. Okay. And one more question I am writing. 11th sum. Limit x tends to 2. Limit x tends to 2, x raised to 5 minus 32 upon x minus 2. Okay. So now, students, we have been finalizing one section. So all of you please concentrate and try to understand the logic of this. Now, in sum number 8, it is very simple. We don't have anything in the denominator. Which denominator is 1. So directly we have to take limit, replace x by 5. So this will be 3 into 5, 15 plus 5. So the required limit is, students, 20. Now in the next sum, students, in sum number 9, also students, we have to simply take limit. Replace x by, when you take limit, we don't write limit. 2 minus 2 into minus 3. Minus 3 into minus 2 will be plus 6. 2 plus 6 is 8 and cube root of 8 is 2. So the answer of the limit is 2. So these questions are very logical, very easy, students. But the main part of the sum is to understand what to apply and which formula, students, to apply. Now this is the specific type of sum. If I take x as 0, denominator and numerator both are non-zero. Check. If I take here x equal to 0, this is 0, this is 0 plus 10. So directly I can take the limit. 10 divided by 5, so the limit is 2. Limit cannot be substituted directly, students, if after substituting the limit, the value of numerator and denominator, students, at a time becomes 0. So here if I take x is equal to 0, denominator is 5, numerator is 10, so the answer is 10 divided by 5. So now in the 11th sum, to apply this formula which I wrote today, x raised to n minus a raised to n upon x minus a is n a raised to n minus 1. So students, to apply this formula, I should change this as a raised to n. So this is written as limit x tends to 2, x raised to 5 minus 2 raised to 5 upon x minus 2. Now check, this is in the form x raised to n minus a raised to n upon x minus a. So the answer is n into a raised to n minus 1. So 5 into 2 raised to 4, 16, 5s are 80. So the final answer is 80. So students, now after doing all the concepts, we have been finalizing section wise. So all of you please pay attention. Now the next target is to do questions 12, 13 and 14. So that students, we complete section B in total. Now students, concentrate and try to understand the concepts. Sum number 12 is very interesting, some students. So please try to understand the basic concepts. Sum number 12. Find the value of limit x tends to minus a. Limit x tends to minus a, x raised to n plus a raised to n divided by x plus a, and the instruction given, n is an odd number, n is an odd number. This is the main instruction. This is the heart for the sum. Students, m is an odd number. So let me do the sum by taking m as odd. Let us take m is equal to 3. This is just a supposition. Suppose m is equal to 3. And 3, students, is definitely an odd number. So this limit changes to limit x tends to minus a, x cube plus a cube upon x plus a. Yes or no? Correct. Now according to the formula, I should have a negative sign between these two terms and these two terms. for that, students, for that, I am rewriting this as limit x tends to minus a x cube minus a the whole cube upon x minus a. Now check. Minus a the whole cube will be minus into a cube, and minus becomes plus. Now if I am going to apply the formula, n is 3, so the answer is 3 into minus a raised to 3 minus 1, so it is 3 into minus a square. Clear? So if I take instead of 3 as n, so answer will be what? N minus a raised to n minus 1. So generalizing, what I am doing now, students, generalizing, we will have limit x tends to minus a x raised to m plus a raised to m upon x plus a. We have answer as m minus a raised to m minus 1. Check. Exactly compare this. Here n is 3, so 3 into minus a raised to 3 minus 1. Instead of 3, if I write n, the answer is n minus a raised to n minus 1. So this way, the sum becomes very easy. But if I directly do in terms of n, students, you will not understand easily. Okay, students, and VSQ 13, question 30. If limit x tends to minus 1, 4x plus k is equal to 6, then find the value of k. Okay, this is very simple. Limit x tends to minus 1, 4x plus k as answer 6. Then students, we have to find the value of k. Okay, replace x by minus 1, so this becomes minus 4 plus k, and the answer is 6. So k will be 6 plus 4, that is 10. Nothing can be easier than this. If I write here k is equal to 10 and take the limit 10 minus 4, you will get the answer as 6. Now the last VSQ, students, VSQ 14. The question is like this. Limit x tends to 3. It is 2 divided by 3x plus k is equal to 1 by 7. Then students, here also we have to find the value of k. Now apply division working rule. Limit of f upon g is equal to limit of f upon limit of g. So this changes to limit of x tends to 3 to upon limit of x tends to 3x plus k, and this answer is nothing but 1 by 7. Limit of 2 is 2. Here take 3 into 3, 9 plus k is equal to 1 by 7, cross multiply 14 is equal to 9 plus k, so k is equal to 14 minus 9, that is 5. So this is what answer, students. So this completes, students, our section B. Now section C we have already completed. Section C, students, we have already completed. And now, students, we are going to finalize section D. And for that, we have to concentrate on the formula which we have written today. Students, section C. In the last lecture I taught you that explain the meaning of x tends to a, we have written. Explain the meaning of x tends to 0, we have already written. Define the limit of a function, I have already told. State multiplication working rule, we have written. Division working rule. and state the standard form of limit of a polynomial. That also students, in terms of theory, we have written check. It is limit of a polynomial function. Now students, section D, in the last lecture we have completed up to sum number 11, and now we are to start with sum number 12. Now here, for most of the sums, I am reiterating that I am going to give a new formula, and that formula, students, all of you have to very carefully understand. Let us derive the formula before starting section D, sum number 12. I am deriving a new formula. This is not given in our textbook, so all of you pay attention. Limit x tends to a, x raised to n minus a raised to n upon x raised to n minus a raised to n is what? Students, if you don't understand the derivation, it is absolutely fine. You have to only remember and memorize the problem. Derivation is not there in your syllabus. You have to only memorize the formula. Say the derivation goes like this. Limit x tends to a, x raised to n minus a raised to n upon x minus a. And here I write x raised to n minus a raised to n upon x minus a. To apply this formula, I need x minus a. So I have divided by x minus a in the numerator, and I have divided by x minus a in the denominator. So again I am telling derivation not important. Now apply division working rule. This is f and this is g. So this becomes limit x tends to a, x raised to n minus a raised to n upon x minus a, divided by limit x tends to a, x raised to n minus a raised to n upon x minus, sorry, here I should have written n, sorry. Now, check, this numerator part is nothing but n into a raised to n minus 1. Denominator part is m into a raised to m minus 1. So, if I take this power in the numerator, this will be a raised to n minus 1 minus m minus 1. So, this becomes n by a raised to n minus n. Minus 1 plus 1 gets cancelled. So, derivation is not important. You have to only remember the answer of this, which is n by m, a raised to n minus n. This is important. And this is true when n is any power. Let the power be a rational number or irrational number or fraction. This formula, students, is universally applied. So derivation, I am telling you, need not remember. Remember only the formula. But as a teacher, I cannot resist giving derivation. Now, how to apply this formula? I will take some number. First, I am taking, students, some number 13. Then I am taking some number 16. Then I am taking some number 17. Check how I am applying this formula. I am doing section C sum number, sorry, section D sum number 13. It is limit x tends to 3. X raised to 6 minus 729 divided by x raised to 4 minus 81. Okay, and then students, I am writing sum number 16. It is limit x tends to 1. x raised to 7 by 2 minus 1 upon x raised to 3 by 2 minus 1. Okay, students, check in both these sums. I am going to apply this formula which I have written or which I have written. Now students, pay attention. In numerator, x and a must have same power n. Check this powers of x and a must be what? N. And denominator must have same power n. That's all. So 729 must be modified in power 6 and 81 must be modified in power 4. Then only the powers will be same. Now you can easily write this as limit x tends to 3, x raised to 6 minus 3 raised to 6 because limit is 3. So this has to be modified in power of 3. And 84 is 3 raised to 4. So this is x raised to 4 minus 3 raised to 4. Now check. It is in this form. X raised to n minus a raised to n, x raised to 6 minus 3 raised to 6, and denominator is x raised to n minus a raised to n, x raised to 4 minus 3 raised to 4. So apply the formula n upon n. This is n. I am showing you. This is n. So the answer is n upon n, a raised to n minus n. So this is 3 by 2 into 3 square, 9 into 3, 27 divided by 2. This is your answer. You get 4 marks for this one. Students, for this much only we get 4 marks. So this is very, very interesting. Now here you are worried that how will we get this as power 7 by 2 because these two powers must be same. Means here 7 by 2 then here also. Now my dear students, 1 raised to any power is 1. 1 raised to, I am showing this, any power is always 1. So 1 raised to 7 by 2 will be also 1, and 1 raised to 3 by 2 will be also 1. So this is written as limit x tends to 1, x raised to 7 by 2 minus 1 raised to 7 by 2, x raised to 3 by 2 minus 1 raised to 3 by 2. 1 raised to any real power is always 1. So x raised to n minus a raised to n. X raised to 7 by 2 minus 1 raised to 7 by 2. So the answer is n, which is 7 by 2. This is x raised to n minus a raised to n. I am circling and writing this as n. I am circling and writing this as n. And it is 1 raised to 7 by 2 minus 3 by 2. I told you 1 raised to any power is 1. So this will be 1, 2 and 2 gets cancelled. So the answer is 7 by 3. Now you can develop a shortcut. If this was 17 by 2 and if this was 13 by 2, the answer would be 17 by 30. You can make any number of sums based on this, students, with your shortcut. You can easily apply the concepts in basic students. So this is the advantage. This new formula is not given in your textbook. So write this formula in textbook, in Fairbook, and whenever you sit to practice this formula, you have to mention. So I think now you can easily do the remaining questions of section D, but do not worry, you can try on your own. As students, we will complete it in the next lecture. So my today's intention was to introduce these two new formulas which students we have already done, and this is the core concept of limit, which is always developed and understood. So try to understand this sums. Again, focus on this two formula. This is the formula which is not given in textbook, and reiterating, write it in your fair book, rough book, practice book, whenever you sit to practice. So here we conclude the lecture, students. Next time we will complete section D and start with the remaining sums of section. Thank you, students.